Good morning, students. Today we are going to discuss nomenclature of coordination compounds. There are some rules to name any coordination compounds. One by one we will study, we will discuss those rules. First rule is that as in ordinary compounds, first we write the name of cation and then we write the name of anion. Similarly, in the coordination compounds, first we check that coordination compound is cation or the counter ion is cation. If counter ion is the cation, then first we write the name of the counter ion, and if the coordination sphere is cation, then we write the name of coordination sphere first. First of all, I will tell you how to write the name of coordination sphere. As you know, in coordination sphere, two parts are there: central metal ion and the second part is ligands. If the coordination sphere has only one type of ligands, then it is called homoleptic complex. Homoleptic complex if it has only one type of ligands. But if the coordination sphere has two or more types of ligands, then it is called heteroleptic complex. Now we will check first homoleptic complex, and in that we will discuss a positive complex. If the coordination sphere has positive charge, then it is called positive complex. If it has negative charge over it, then it is called negative complex. Some complexes are there which do not have any charge, means their overall charge is zero, then they are called neutral complexes. Three types of complexes are there on the basis of charge: positive, negative and neutral. This is a positive complex. During the writing name of complex, means coordination sphere, as you know that what we write in the square bracket is called coordination sphere. First we write the name of ligand along with its number. Now here the name of ligand is amine. NH3 is called amine and 6 molecules of amines are there. So for 6 we use hexa, then amine, then the name of central metal ion, means cobalt. Then in the small brackets we write the oxidation number of this central metal ion in Roman numbers. Now there is a question that how to assign the oxidation number. That is very simple. We have to assign the oxidation number to this cobalt. So let it be X. Let the oxidation number of cobalt be X. Now the charge of the ligand. Here amine is a neutral ligand, means it does not contain any charge. So its overall charge is 0. So 6 into 0. And the oxidation number and charges of ligands. Sum of the oxidation number of central metal and charge of the ligands is equal to overall charge over the complex. That is plus 3. So here we get plus 3. So what is the oxidation number of cobalt here? Here the oxidation number of cobalt is plus 3. We will write it in the Roman numbers in this way. And as this coordination sphere contains overall charge, so it is an ion. So we will write ion at the end. So the complete name of this complex is hexaamine cobalt third ion. Hexaamine cobalt third ion. Okay? Now, we will take one more example. CrCO. CO. Here CO is the ligand. It is carbonyl. It is called carbonyl. So what should be the name? 6 hexa carbonyl chromium. Hexacarbonyl chromium, and again the oxidation number. Now I hope that you can see that oxidation number of chromium is 3 here, as carbonyl is a neutral ligand. Carbonyl is also a neutral ligand. So its overall charge is 0. So this charge over the complex is due to only this chromium. So it is plus 3. Oxidation number of chromium is plus 3. And iron. Iron. Always remember that oxidation number of central metal atom or ion can never be negative. It can never be negative. It may be 0 but not negative. Alright? And here 6 is written. What is 6 here? 6 is the coordination number of chromium. 2 numbers we have to check: oxidation number and coordination number. Oxidation number, which is used to form simple compounds, and that is plus 3 here. And coordination number is the number of electron pairs which is accepted by the central metal ion from ligands. Here each carbonyl is donating 1 electron pair to the chromium, and 6 carbonyl molecules are there. So overall 6 electron pairs are accepted by the chromium. That's why its coordination number is 6. Generally, the coordination number of each metal is definite or fixed. Now, this coordination sphere is a cation. This is a cation. Now, if I use any counter ion, then that should be an anion, because to counter this positive charge we need negatively charged species. And if I use any negatively charged species, say I use chloride ion, Cl minus. Now the charge of chloride ion is -1 and here it is +3. So I have to take 3 here, and then I will not write this +3 here because it is now countered. In this case, in place of ion, I will write the name of this anion in the end, that is chloride. So now the name of this compound, coordination compound, is hexacarbonyl chromium 3rd chloride. Now there may be a question that 3 chloride ions are there, why I did not write trichloride? Because when we go out of the complex, then we use the simple rules. For example, AlCl3, you do not write it aluminium trichloride. What do you write it? You write it aluminium chloride only. Similarly, if you will write the name of this compound, you will write chromium chloride. You will not write trichloride. Similarly, we are writing here. We do not indicate the number of counter ion. Now we will discuss a negative complex, because some rules are different for negative complex. For example, I can take FeCN6 3 minus. Now here Cn means cyanide, and in case of complexes or coordination compounds we call it cyano. This cyano has -1 charge and 6 cyano ions are there, so overall negative charge is -6. So what will be the oxidation number of iron here? First we calculate that. Let it be X. Let the oxidation number of iron be X. Then 6 ions of cyano are there and charge of 1 ion is -1, and this sum will be equal to the overall charge, that is -3. What will we get? X minus 6 is equal to -3, that is X is equal to +3. X is equal to +3. So here the oxidation number of iron is +3. Coordination number you can check. This is 6. Now for writing the name of ligands, same rule is there. Hexa, then the name of ligand, that is cyano. Now when the complex has negative charge, means in case of negatively charged complex, we write the Latin name of central metal ion, the name from which its symbol has been derived. Now the symbol of iron is derived from its Latin name, which is ferrum. What is the Latin name of iron? Ferrum. So we will take ferrum. And in case of negative complex, the name of the central metal ion ends with ate. We write ATE in the end. So it will be named as ferrate, hexacyanoferrate, and then oxidation number, and then iron. Hexacyanoferrate, third iron. This will be the name of this complex. Now, this is a negatively charged complex. If I want to counter this charge, I have to use any cation. For example, I take potassium. Now you know that potassium ion is K plus. So how many potassium ions do I require to counteract this charge? 3. So I will write K3 here, and then I do not need to write this minus 3. K3 FeCN6. Now counter ion is the cation, so I will write the name of counter ion first. Means I will write it here. Potassium. So now the complete name of this complex is potassium hexacyanoferrate, third ion. Always remember that the name of coordination sphere is always written in continuation without any break. But between the name of counter ion and complex, there will be a break. Okay? The name of coordination sphere will always be written in continuation. The name will be broken only where we are indicating any number or any symbol which defines the position of anything. Okay? Let's take one more example of negative complex. NiCl4 2 minus. Always remember that the name of negative ligand ends with O. Name of negative ligand always ends with O. So in general you call it chloride, but here we will call it chlorido, because now this is the part of complex. Now this Cl minus is used as ligand. Then so we will write chlorido for it, not the chloride. 4. So tetra. Chlorido, and then nickel. Now nickel, the symbol Ni is taken from the English name only. So we do not need to go for its Latin name. We will take this English name and we will end the name with 8 because the complex is negatively charged. So tetrachlorido nickelate Then the oxidation number of nickel, let it be X. In the same manner, 4 ions of chloride and charge of 1 is -1, and that is equal to overall charge over the complex. X minus 4 is equal to -2, or X is equal to +2. So what is the oxidation number of nickel here? It is +2. So we will write in Roman numbers in the small bracket and ion. So the complete name of this complex is tetrachloridonickelate second ion. Alright, and if I use any counter ion, for example, this time I take magnesium, suppose. Now the charge of magnesium is +2 and the charge of complex is -2. So this +2 and -2 will be countered, so I do not need to write the charges here. So it is MgNiCl4, and the name of this complex will be, first, the name of counter ion, as counter ion is the cation here, magnesium, and then the name of complex tetrachloridonickelate third. Now we will not write ion in the end because we have countered the charge. Okay. Now in all these examples we have taken the unidentate ligands. Actually ligand has denticity. What is the meaning of denticity? That how many electron pairs can be donated by the one molecule of ligand at a time. How many electron pairs can be donated at a time by the ligand? It is called its denticity. So here all the ligands which we have seen till now are unidentate because one molecule of the ligand is donating one electron pair. But there are bidentate ligands, there are tetradentate ligands, and there may be hexadentate ligand, okay, which can donate more than one electron pairs at a time because they have more than one donating sites. And in that case the coordination number will be calculated in a different way. For example, here we know that chloride ion gives only one electron pair, so we can guess that the coordination number of nickel is 4 here. Coordination number of nickel is 4 here. But if we take any bidentate ligand, say I am taking ene. What is ene? This is from ethane. From both the carbons, one hydrogen is removed and one amine is added. Okay, so its name is ethane 1 2 diamine. NH2 is called amine. Check the spelling. In case of NH3 we have written amine, AMMINE. In case of NH2 we write amine, AMINE. Okay, single M is there. It is also known as ethylene diamine in common system. Now during the writing name of this compound, first we will write the name of ligand. 3 molecules of ligand are there, but there is a problem that here in the name of ligand there is also a number indicating word, that is di. If the name of ligand contains any number indicating word, then I cannot use di, tri, tetra to indicate the number of ligands. In this case, for 3 I will use tris. If the number of in here 2, then I would have used bis for 3, tris 4, tetrakis 5, pentakis, in this way. Okay, tris, then ethane 1 2 diamine, I can use bracket here to show that this is the name of ligand completely, and then cobalt. Now oxidation number of cobalt. Now how can we determine the oxidation number? This you know, ene is also a neutral ligand, so the oxidation number will be +3 only, and the name will end with ion. Tris, ethane 1 2 diamine, cobalt, third ion. Now to determine the coordination number of cobalt, we have to check that ene is a bidentate ligand. Means one molecule of ethane 1 2 diamine donates 2 electron pairs simultaneously. It has 2 nitrogen atoms, and both nitrogen atom contains 1 lone pair. So both these nitrogen will donate 1 lone pair of electrons to the cobalt. So overall 6 lone pairs will be accepted by the cobalt here. So coordination number is 6 here. Coordination number of cobalt is 6 here. Okay. In the next session we will discuss the heteroleptic complexes. Thanks.